Assalamu alaikum wa rahmatullah. Hi everyone. I am Muhammad Sawad, taking graduation from Malabar Christian College, affiliated under the University of Calicut, Kerala. So, I am here to present a paper entitled Radiation Technology, New Potencies for Environmental Protection. So, the goal of my paper is to discuss the application of radiation technology for wastewater treatment. So, water is the most important life factor for all living systems, as you all know. But a lot of water is contaminating nowadays. Even our drinking water, population growth, coupled with declining freshwater supplies, has necessitated the development of technologies to reclaim the potable water from wastewater. So, this paper uses data from the credible sources like International Atomic Energy Agency, United States of Environmental Protection Agency, and other organizations that deals with radiation. I read this paper and it is a detailed study and compilation of various researches made on this area, that is wastewater treatment by gamma radiation. So, water disinfection by chlorination can cause formation of carcinogenic chlorinated organic compounds. The reduction of microorganisms in wastewater treatment by chlorination was found to be insufficient. Among all the possible alternatives of wastewater treatment, radiation processing is found to be very effective and in destroying the organic compounds and biological contaminants. So, why gamma radiation? Gamma ray emitted during the basically it is a electromagnetic radiation emitted during the decay of radioactive atoms, which is has a relatively high penetrating power, and it requires a lower dose of radiation for the removal of pathogens in comparison to electromagnetic and in comparison to other electromagnetic radiation. Now, how it affects the elimination of microbial loads? First of all, a study conducted the presence of fecal coliform. The occurrence of fecal coliform has been widespread that cause severe illness and death. E. coli, as you know, is E. coli is a fecal coliform and is a strong indicator of sewage or animal waste contaminant. The occurrence of fecal coliforms it affects the immune system of children under 5 years. And the effect of gamma radiation in microorganisms is figured out by means of D10 value parameter, which calculated at the reciprocal of the slope obtained in the regression analysis of logarithmic inactivation. After irradiation, doses of 0.32 kilo gray is a unit of radiation, and 1 gray is equal to 100 radiation. So, the dose of 0.32 kilo gray to 0.4 kilo gray are needed for 1 log inactivation of total and fecal coliforms in primary wastewater, and for secondary wastewater, 0.30 to 0.36 kilo gray is required. In total, complete inactivation which no regrowth has achieved at dose of 1.5 and 2 kg in primary and secondary wastewater respectively. In a study, phenoxide type of acids like 2,4-dichlorophenolactic acid were chosen as model compounds, and their decomposition in aqueous solution when radiation induced was investigated. And also pesticides like 4-chlorophenoxyacetic acid, which are widely used as insecticide throughout the world, The large use of these type of pesticide in agricultural activities is one of the main cause of pollution of surface and groundwater. When 4-chlorophenoxyacetic acid solution were irradiated within range of 1 to 3 kg, observed a decrease of 80% from the initial amount. And next one, nematode egg. One further study in the water being added with parasite nematode Meloidogyne javanica, which is they are the most damaging of all nematodes in pineapple fields, causing stunting, yellowing and dieback of plants. They were added and incubated up to 7 days. It is noted that at also 1 kilogram, only 65% of the nematode eggs in the irradiated sample were inactivated, and at 5 kilogram, about 98% of the nematode egg deactivated. And how gamma radiation affect the physical and chemical measurements. In an experiment, a sample of wastewater were collected and the facility used in irradiation is gamma cell. As you can see, the presentation is a Canadian made supplied with cobalt, which has calculated dose rate of 2 million rad per hour and radioactivity of 50 kilocurie. In January 1985, all tests in the study were taken as an average of 3 samples, subjected to the same absorbing dose. The dose used were 0, 10, 25, 50, 100, 200 and 500 kilorad radiation. The dose rate in recent time was approximately 0.2 million rad per hour. The irradiation time for these doses were 0, 3, 7, 30, 60, 90, 120 and 150 minutes respectively. So after irradiation, ionizing radiation has drastic effect on the organic material in the wastewater. Because of the strong activity of gamma radiation, energy that changes the characteristics and the structure of the pollutants in wastewater. But the electrical conductivity and hardness of water remains unchanged, while the pH, fat, oil and total dissolved solids concentration, etc. has gradually changed. And in another research conducted by H. Hambro and Zanetti, Water Authority of Jordan, for the remediation of wastewater and polluted water by irradiation is found effective. This research carried out within the frame of International Atomic Energy Agency Coordinator Research Project. The experiment was concentrated in Jordan, which mainly depend on the groundwater as the major source for drinking and water supply, but are affected by continual quality degradation due to effects of overexploitation, increased disposal of organic wastes, septic tank wastes, wastewater infiltration from sewage treatment plant. So they collected the samples from the spring water, which microbically contaminated, to study the effect of irradiation on the microbial content and to find the effective dose required for the disinfection of such type of water. The collected samples are irradiated using cobalt. They researched gamma irradiation for 100 to 300, 500, 750, 1000 and 2000 grays. The collected samples before and after irradiation were analyzed and noted the microbiological content at the laboratories of Water Authority of Jordan. After thorough observation, it was found that the amount of E. coli gradually decreased at the radiation dose of 500 gray, and concluded that at also 1 kilogram is the optimum dose that can be used to achieve both goals: to complete water disinfection and to ensure no bacterial regrowth in the drinking water. So, when we irradiated using gamma ray, a question arises: can we drink the irradiated water? The use of radiation technology for wastewater treatment received attention in recent times. Now the big question: can we drink it? So under the leadership of WHO, World Health Organization, 35 different kinds of irradiated food at a radiation dose of less than 10 kg were fed to healthy person. After 90 days of careful observation, complete physical examination were carried out before and after consumption of irradiated food, and no adverse effect were found on their daily activity. The CVO studies provided no existence of treatment-related toxicological effect, and FDA also concluded that studies were well conducted and explained the absence of adverse effect. In addition, the toxicity of disinfected wastewater using gamma radiation is lower. The irradiated wastewater is fit for irrigation industry usage and also for the sustainable management of fragile freshwater resources for developing countries. So I am concluding. So after thorough study and reference by this paper, I am concluding that radiation processing is found effective in treatment and disinfection of microbically contaminated water. We can reuse the water for agricultural purpose and for drinking also. Pesticides, bacteria, and other microbes were deactivated using radiation.
Muhammad Sawad, that is a nice presentation, and hope in immediate future you will be putting your own content.